Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at the Commodore 1084, and specifically this version. This is the boxy, like what I like to call the boxy Philips version. It was manufactured by Philips for Commodore. I think it was sold under names like Magnavox and Philips as well. This monitor was sold around the world in many different versions. I mean, 1084, 1084S, S for stereo. This is the mono version, and PAL, NTSC, maybe other markets as well. Not 100% sure about that. One of the things I absolutely love about this monitor is that it's incredibly versatile. It has TTL RGB, analog RGB, composite video, Luma Chroma, which is like S-video, and of course audio input because it has a built-in speaker. And it has a very clear, sharp picture with a high resolution CRT, lots of controls, vibrant picture. It just works really well. One of the things this thing doesn't do though, and I've talked about this in other videos, is if you have a North American version, it only decodes NTSC color for composite video and S-video. And if you have a version in the PAL markets, it only does PAL. If you do use the RGB input though, you don't have any PAL or NTSC color decoding, and this monitor works great with both 50 and 60 hertz signals. The circuitry in the CRT actually adjusts the height of the image based on whether you're using 50 hertz, which has more lines, or 60 hertz. So you don't even have to adjust the controls, although there are lots of controls on the back for height, width, position, stuff like that. Things that are often normally inside a monitor are available on the outside of this monitor to make adjustments with. Now, what I want to focus on in this video is the fact that the RGB input, the analog RGB input, actually has some limitations. For demonstrating this problem, I'm going to be using my Sony PlayStation 1. Even though it's a North American version of the console, it does support RGB output, just wasn't very common to be used here in North America. But in the rest of the world, everyone was connecting this to their TVs and their monitors using a SCART connection, which would natively use RGB. The cable I'm using is actually a component PlayStation 2 cable. Has the same pinout though, but what it was missing, which is why you see these extra wires, is I added an S-video cable to it, and I also added another cable for composite video output. Now, when I turn this on, you can see the image looks kind of okay, but it very quickly gets screwed up looking. And I can assure you that the monitor is working perfectly. There is not a problem with the monitor. This is that subtle problem with the monitor that I want to try to address in this video that should fix this problem. What exactly is happening? Why it looks perfect sometimes and then other times it doesn't look right. The reason why we're having an issue is this monitor expects an RGB video signal, which is coming from the console perfectly, but it also expects a sync signal. And that sync signal has both pulses for horizontal and vertical sync. And that goes into the back of the monitor on the little DIN connection. And in fact, I'll turn this off and I'll get the cable unplugged out the back. And we'll take out the contraption I'm using on the back here to connect up the console to the monitor. So the 1084 uses a DIN jack for RGB. I have a little adapter that I made, just goes from the normal DIN to a standard DE9, the same pinout as any Commodore 1084. And the cable I'm using for the console just has normal RCA jacks, and it has RGB plus audio right and left. Well, the thing is, when you're in RGB mode on the Sony PlayStation 1, there is no sync information in the RGB signal. Sometimes it's possible to embed the sync information in green, called sync on green, but that's not what this console is using. This console, like I said, was designed to be used with SCART cables, and with the European SCART standard, the sync information, even when you're using RGB, always came over composite video. So basically with SCART, what you're doing is you're feeding composite video into the monitor, and what that does is it would display just a normal composite video display of whatever computer game console you're using. And then there's an extra pin on the SCART connector that when you, I think, ground it or maybe give it 5 volts, it switches over to use the RGB input. So that means that all the sync information is still coming through the regular composite video connector, which is this cable here I've added to this cable. And then the RGB information is coming through these jacks. Now this little adapter you see me holding up here, if I get closer to the camera, all this is just a DE9, and I soldered it together with some jacks from an old stereo or something. I don't remember where I stole that from. So this adapter lets me take this type of cable, connect it up to any DE9 RGB monitor, which happens to be like this 1084. Now specifically, the issue we were seeing is that the sync input on the monitor expects a normal TTL sync, and it doesn't like getting a composite video signal, which has the sync information embedded into it, but it has all the other video information embedded into it as well. And that's why when you first turn on the console and there's not a lot of stuff on screen, like just the logo, it's fine. But as soon as a bunch of text and graphics come up on the screen, what happens is the IC in the monitor that separates the sync signal gets confused by all that video information that's mixed in on the composite video signal and completely loses sync, which is why the picture started rolling and getting really ugly. Now, we already know that the 1084, if I plug this composite video signal into the back directly, and I switch the monitor from RGB to composite video, it's gonna work. That means there's already circuitry in the monitor to take the sync information out of the composite video signal and then provide it to the rest of the circuitry, which runs the deflection. So the monitor is capable of doing it. It's just that when you press the button on the front here to switch over to RGB, it has trouble separating that sync information, I think, because it's looking for a 5-volt sync, and basically that causes an issue. Now, this problem is not unique to this Commodore 1084. I actually plugged the PlayStation into other 1084 monitors I have using the same little adapter, and they also had the same issue. The thing about this monitor that makes it different than those other ones is that this one, in some markets in the world, already have a SCART connector on the back, which means they actually have the ability to display RGB with composite video as the sync signal and not lose sync. And that's where a mod that Mark over at the Retro channel came up with on how to convert a monitor like this that's lacking the SCART jack and lacking the extra little things inside to allow it to decode the composite video as sync. And he outlined exactly what parts you need, which is just a few, and what mods you have to do to the monitor PCB to allow this to work. And doing this mod should fix this, so the PlayStation should work, but it should also not render the monitor useless, and I should still be able to use anything else with it, like IBM CGA or Commodore Amigas or Atari STs and whatever. It should all still work perfectly, and that just means more versatile, because now I can plug in things like my PlayStation and other game consoles that have just a normal SCART connector. And in fact, speaking of SCART, I have a SCART jack right here. It just happens to be plugged into a little, another SCART connector, but I stole this SCART jack off of like some piece of hardware I had recycled a long time ago, and I thought I might as well install this into the back of the monitor, because then I'll actually have a SCART jack. First time I don't have any monitor with SCART. It's just not something you have in North America. And if you have one of these boxy monitors, you probably noticed that there is a cutout on the case for the SCART jack. In fact, mine has fallen out a long time ago, and I had to use some hot glue just to hold in the blanking plate. Well, might as well add that in so I can have TTL RGB, analog RGB, and SCART all on the same monitor. How freaking awesome would that be? Okay, I think what I need to do now is just clean off the bench. I'll get the PlayStation out of the way and take the back cover off. And just FYI, don't open up a monitor unless you know how to do so safely. Lots of high voltages and things in here, even when it's turned off, that could give you a big shock. So really don't do it unless you know how to do it safely. If you don't, find someone who does, and they can maybe do this mod for you. Oh, by the way, I wanted to mention, if you notice, my 1084 has a gray cable. And that's because this is the cable from the Apple II GS monitor I had in the last video, where I said I would swap it onto the 1084. And I did, because the 1084's cable, which is fixed, was black and very stiff. And this is a nice soft cable. And I also shortened it, so the length is not as long. It's not always in my way. This is the monitor that I always sort of keep around handy to have on the bench here if I'm testing out a computer or whatever. So I needed it to be, well, easy to move around and not have a cable that was always in the way, which is basically what was always happening with this thing, which really freaking annoyed me. Unfortunately, the little wire management thing is busted, so I have to install this little washer into here. That just holds the power cable in place, but you do need to remove that while you're taking the top off, and that's because this part of the case comes off when you lift up like that. Okay, a few things I want to mention right off the bat. This monitor, as I mentioned, is the NTSC version of the monitor. Normally it has a large RF shield that covers the bottom of the PCB. I'd removed that a long time ago because typical with these monitors is you have some cracked solder joints, especially around the flyback, that keeps the monitor from working. And you do have to remove that shield in order to gain access to the connections on the flyback. I don't remember exactly how hard it was to remove the shield, but I think it was a pain. And therefore, I really recommend that you just cut it off. And it looks like I actually tore some of the traces on the PCB along the top edge, and that was from that removal process. And I think I was trying to desolder it. I don't really remember the details, but I really recommend getting some sharp side cutters and just cut off the little tabs and whatever that's holding that on. It's not necessary. It's not installed on this monitor in the rest of the world. It is strictly a North America thing, and there's no difference in the PCB between North America and the rest of the world. So therefore, for your own sanity, just cut it off so you can do this work and also try to fix up your bad connections on your flyback. Now, something else I want to mention, I should have said this right from the beginning, Mark's video on doing this mod is a great tutorial and it's going to be better than this one. So I highly recommend you go watch his video if you're going to do this mod. I also recommend you just subscribe to his channel because it's awesome. He's really great with this old retro stuff, especially when it comes to modifying things for better video quality and all sorts of stuff. Awesome channel, highly recommend it. What I'm really doing here is I just want to see if the mod that he did to his PAL, he's in Australia, his PAL region monitor works on the NTSC monitor. I'm pretty sure it should. We both think that the PCB is exactly the same between the PAL and the NTSC one. It's just the components that are installed are a little bit different. As far as I can tell, this monitor made by Philips in North America had at least 7 different versions, and the Commodore 1084 being one of those versions. And the things that were different among them is sometimes it didn't have analog RGB, sometimes it didn't have TTL, sometimes it didn't have Luma Chroma, it only had composite video, sometimes it had a low-res CRT, sometimes it had a high-res CRT. There were all sorts of different versions like that. And of course, those require changes to the boards. And then NTSC PAL differences as well for different regions of the world. So there were just lots of jumper links and mods, which is pretty much why we have this list of modifications we can do to this one to enable this SCART stuff that wouldn't normally be something you could do in North America. And I'm pretty sure this should work on this monitor. Okay, there's something else I want to talk about while I'm in here, and it's the Flyback transformer. I mentioned that this one had issues where there were bad connections on the bottom that I had to fix up, and this was years ago when I fixed those up. But notice how this Flyback looks. It's kind of a white plastic that's yellowed over time. It has the high voltage anode connection with a red cap. And then there's this black wire, which is a high voltage connection, I think for focus and screen voltage, that comes out of the Flyback off a different winding. And this goes to the neck board. And the neck board is actually how you can adjust the screen and the focus voltage. So there's like some voltage divider stuff happening. We'll just pop this off so I can show you what I'm talking about. So this connection from the Flyback comes and goes into this little box. Inside of this, there's a potentiometer and some other high voltage stuff. And out of that, I think this is the screen voltage. It goes down to the connector that plugs into the CRT. And I think on the PCB, there's also a connection for the focus voltage. The screen voltage on this color CRT can be pretty high. I think like, you know, in the range of a couple thousand volts or whatever, which is what this connection is. The reason why I brought this up is the high resolution version of the Commodore 1084, this one you're looking at right here, came with at least 3 different Flyback transformers from Philips. This one with the blue and the red cap is the earlier one and the reliable one. These don't ever seem to have problems. Later, there was another version that's like a white version, and it has this voltage divider stuff that's on the neck board built right into the Flyback. And those are horrible and they seem to fail. And it's the Flyback itself that's failing. And if you have a monitor with one of those and it hasn't broken yet, you can pretty much be sure that it will anytime, and you're going to need to replace the whole Flyback to get your monitor working again. Luckily, there's a company out there that makes replacement Flybacks, and I'll put a link in the description to a video that Mark at the Retro Channel has made on this process. And you can order one of those, and you might want to just order one to have one in stock. But from what we can tell, only the later version that doesn't have the blue cap, so it has this red cap, but then doesn't have the blue cap and has 2 wires that come out of it, one for screen and one for focus, those are the ones that all universally fail. And what happens is they go short inside, keeps the monitor from running, it makes a high-pitched squeal, and you get no picture at all. There's a third version of the Flyback that's black, and those also don't seem to fail. We have not been able to find any reports of those failing or any reports of these failing. All of the failed Flybacks that we can find after doing some research looking at videos on the internet are the later versions that don't have the blue cap. This monitor, if I look at the back cover, it says it was made in December 1987. It's clearly printed on the back. And I have a couple more of these monitors here in the basement, and all of them seem to be made 1988 or 87. And all of them have the better Flyback, the one that doesn't fail. And the reason why this even came up is I was asking Mark, I'm like, Mark, all your 1084s, this boxy one, seem to die with the Flyback, and yet I haven't run into that at all here in North America. Well, it seems that these were pretty popular in like 87, 88, these monitors, and that means they generally have the better Flyback, either the black version or this early white one with the blue and the red caps. And it seems that if your monitor has like a 1989 date code on the back, then it's going to have the later Flyback that will fail. And you can look through the grill or the plastic cover through the slats that are there with a flashlight, and you can clearly see the blue and the red caps on your flyback. So if you want to know for sure, without taking the monitor apart, just look inside. You should be able to see that it's either a black flyback, which is fine, or it's got the blue and the red cap, which is fine. And if you don't see the blue cap and you just see like this black wire plus another black wire coming out of the bottom of the flyback, those are the bad ones. And I'll put a picture on screen so you can see what I'm talking about with the bad ones. I've never seen one personally, but Mark has a whole bunch of them and took some photos for me. Also, one thing to mention is that replacement flyback, the one that Mark uses to get his monitors working, wouldn't even work on this monitor with the way that this neckboard works with this high voltage divider and potentiometer. These controls themselves on that later monitor, I think, are just right on the flyback. So you'd have to do some modifications to the neckboard to even use one of those. So that would be if this flyback actually died. Luckily they don't. So there really isn't a problem. In fact, when it comes to issues with this monitor, there really aren't any. The caps are rock solid. They work really well. I've never had to replace a cap on this whole thing. And generally, the only thing that goes wrong are bad solder joints. This thing did have a fault where one resistor went open, and it was like a 3 or 4 ohm resistor, and it had the effect of making the audio amplifier not work. And I think the power LED didn't work. And I fixed that a long time ago before I made a video about it, but it was relatively easy to find the resistor had just gone open, and I replaced it, and the monitor worked perfectly again. So now we're going to try to add the SCART connector. You can see the footprint for it right there. There's a few mods on the board, and then the rest of the mods all happen underneath this area. So that means I'm going to need to remove this power supply board and just slide this out so that I can get to that part of the PCB. Okay, so first off, to get the power supply out, generally you just pull it out and that's it. So I'm going to unplug this connection. That's the actual power that comes from the power supply, goes to the main board. Also on the front, this connector needs to come off the power supply, and this is for the degaussing circuit. So this theoretically comes out. Now the issue on my monitor at least is there's a ground strap that's permanently soldered from the power supply down to, let's see, is it actually permanent? Yes, it's permanently soldered from this to the yoke. So there's really no way to get this completely apart. So all I can really do is just take this and move it all kind of over there. Okay, so once again, I'm going to refer to Mark's video for better instructions on how to do this mod. The gist of it is there's a transistor that's right there. I'm poking at it. That needs to be moved over here to this location, TS405. There are a couple of resistors we have to add onto the board. I'm just looking at the paper here, R402, R403. There's a 2.2 microfarad cap we have to install at C401, which is right there. And then there are some jumper links that we have to install onto the board in various locations. Incidentally, if you're wondering what this vertical board is, this is the TTL RGB to analog RGB converter. So this is what takes the CGA style input and then, well, essentially converts it to analog, because that's what a monitor needs. It needs analog RGB. It doesn't natively work with TTL RGB. So that's what this board does. And an older version of this monitor with a different version of this, I don't have it, actually supports Apple II XRGB, which is the RGB used on the Apple III and on the Apple RGB card for the Apple IIe. And it has different color mappings and stuff, and there's a pin on the TTL RGB input that gets set, and that switches the mode of this card. But this is the later version that only supports the regular CGA style video. And then as for the SCART connector, all that has to be done is just to remove the solder on the bottom side so the connector can go on. And Mark says to install jumper link 9289. And the odd thing is 9289 is already installed on my monitor. So yes. So I think what I'm going to do is I'm just going to tilt the monitor up onto its side so I can access the bottom of the board, and I'm going to remove all of the solder and the components that I need to take out, and I'm going to install all the mods. I won't show that process, just go check out Mark's video if you want to see it, and I will come back and let you know if there are any issues, because this is a different monitor than the one Mark did, and if it's all goes smoothly, we'll be able to test. Okay. The mods are completed, and there were some differences between this monitor and Mark's monitor, and I think I have this all worked out. I haven't tested this, so I don't know if it works yet, but I think this is right. So first, let's talk about the sync mod. Moving the resistor T406 to T405, no problem. There was a resistor at 405, I could remove that, no issue. Then I installed the 47K and 39K at R402 and 403. And then I installed the capacitor at 401, no problem, 2.2 microfarad. I didn't find a 2.2, so I used a 3.3. Sure, that's going to be fine. Then Mark said to install the jumper link at 9281, 9247, and R405. So R405 is where we removed that resistor in this above step. So that's no problem when I installed a jumper link in that spot. Where I ran into issues was, well, first off, 9247, I have it crossed out, and up in this corner of the board, this is where TS406 was. I moved it to that TS405 position. On Mark's monitor, there was space to put a jumper link, essentially from the collector of the transistor over to this side where a capacitor 401 is. Well, on this monitor, there's already a trace there. So I didn't have to install anything because the trace is already there and there aren't even holes to install a jumper link. So if you don't have the holes for the jumper link and you just look at the bottom side and you have this trace that goes from that pin of TS406, the collector, and up to this pin of C401, then you're good. You don't have to do anything. And then that brings us to jumper link 9281. On my board, that was already installed in the monitor. That jumper link gets installed right below TS405, right there, 9281. Well, on my monitor, that's already installed. Okay, that brings us to the SCART connector. I just installed the SCART connector, no issues whatsoever. But looking at the instructions, Mark said to install a jumper link at 9289. Well, on my board, that was already installed as well, so I didn't need to do anything. But it turned out there were some other mods that we had to do if we wanted the audio on the SCART connector to actually work properly. Because this is a monochrome version of the monitor, it doesn't have stereo sound, you have to install a resistor at 305 and 306, that's 5.6K. And you have to install a resistor, a 22K resistor at R303. This creates a voltage divider that basically combines the right and left audio jack or inputs on the SCART jack, because it's a mono monitor, and then J9275, this is a jumper link I had to install, that connects this little voltage divider thing to the rest of the audio circuitry on the monitor. You don't have to install that because, of course, you could just use the audio jack on the monitor here, but if you want your SCART jack to be, compliant, you have to install these three resistors and that jumper link. There was one other mod to do, and it's also optional, as this one was, and it's R210 and 220, which are right here on the board. And those should be a 390K for the R210 and a 1K for 220. And what that does is it hooks up the blanking pin of the SCART jack to the main IC on the monitor, which is this one. What that allows this SCART jack to do is be, compliant. The RGB input on SCART was originally designed to have on-screen display overlays. So you'd have composite video fed into it, and then say you had to display some text with RGB. There was a blanking signal, which you would pull, I think, up to 5 volts or 12 volts. And that would basically switch over to RGB. And if you blanked only at the exact spots where your text overlay was, then you would see text overlaid on top of composite video. Most consoles, for instance, when you hook up the RGB, all it does is give 12 volts to that pin, which just sets it to RGB mode all the time. Well, installing these two resistors, a little voltage divider, 390 and 1K, makes its way over to this IC. And then, like I said, that will allow this to work. When you plug an RGB source into there, it will automatically switch to the RGB input, and it should allow the overlay of text, which I don't have anything to even test that with, but theoretically, that should be possible. Mark from the Retro channel gave me the values for all of these optional components because he has a version of this monitor, it's a PAL monitor, and it has the SCART jack installed and it has all those components installed. So we just looked at his monitor to see what was installed, and he checked the service manual, the PAL service manual, to find the exact resistor values for this stuff. None of this is mentioned in the NTSC service manual. Even though the PCB is fully capable of accepting all of those inputs and whatnot, it's just not set up for SCART out of the box. Although it's partially set up for SCART, like some of the jumper links that were already installed allow the SCART to pretty much work as is. It's just the audio wouldn't have worked and that blanking stuff wouldn't have worked. But those are both optional because you can set the switch on the front to switch to RGB, and you can use the audio input on the back here. You know what'd be really cool to do is to take super high resolution pictures of both the top and the bottom of the NTSC and the PAL 1084 and compare and figure out all the differences. Because it would be possible to convert one of these over to work with PAL. I don't think it would be selectable because some of the differences, like the delay lines and the crystals and stuff, aren't something you could just have switchable between PAL and NTSC. But if you're in North America and you want to set up your 1084 to work as a PAL monitor, it would totally be possible. We would just have to do that comparison to figure out what components are different, and then you'd have to source the components. And I think the hardest one would be the delay line. This has a delay line in it, and I think that's for NTSC chroma decoding. But there's got to be some other differences on here. And in fact, there might be a demodulator IC that might be different as well, a PAL versus NTSC version. Although theoretically, the chip that's on here might work with both. It's just that the crystal oscillator that's on here is set up for NTSC color carrier, stuff like that. Anyways, that is not the subject of this video. I think I need to put this thing back together so I can see if this thing works with the PlayStation and then still works with something like my Commodore Amiga, which has the old normal TTL sync. Okay, the monitor is all back together. I do have it plugged into mains, but it's turned off. I'm gonna turn this on and let's see if any magic smoke comes out of it. I'm always worried first time I'm powering it back up. We don't have a speaker hooked up to it, so there's no way for us to hear any audio. Just checking all the connections are on. I think everything is connected and ready to go. Yeah, let's turn this on. 3, 2, 1. Okay, it sounds normal. No horrible sounds. Good sign. Let's turn this back on. I just have to give it a little push on the back. So if you push the power button when the case is not on, it can push the whole power supply out of the back of the monitor. It's not dangerous. It just means you can't push the button. Okay, I think we're on RGB. I'm going to switch over to composite and I'm going to plug in the PlayStation composite jack first. Let's just make sure that that is working still. Get the power onto the PlayStation. Okay. Oh, yeah, no problem. Push the button back there. There we go. Color video. Nice. So it looks terrible because it's composite video. That's totally expected. So I'm going to take this SCART adapter, connect up the video cable, and it has an in and out switch, so I'll make sure it's set for in. Let's see what happens if I plug this in. Nothing. I don't think this is necessarily going to work because right now you can see it's rolling and I have the composite video connected to the SCART jack and that should be sending the sync information in at the minimum and it's not. So that's a bit of a bummer. Yeah, that thing is on all the way and it's definitely set to CVBS. I just have the brightness turned up so we can see the retrace lines. Well, okay, so I guess there's more to the mod than I did. So this part doesn't work. It's kind of my assumption the audio portion would be working because that is definitely hooked up. Definitely hooked up. Okay, so that's the RGB plugged into the correct adapter for analog. Okay. Okay, look. That's good. That is really good. Let's reset the game. So that's working. That is freaking working. Nice! Super sharp RGB freaking works. All right, so if I turn the console on and off and I have a new game in there, let's see if this loads up. That looks good. I'm assuming, well, I don't have any audio plugged in, but yeah, like I said, I don't know for sure if this SCART adapter actually works, but I'm sure it does. I got this with just some random thing at some point I ordered. And all right, we are looking at Mega Man 8, as you can see by the full motion video there. I like this game because it's 60 frames per second and it's very vibrant and it's very bright. And it's probably looking really good. Yeah, I mean, of course it's RGB, it's mega sharp. Look at that. Looks freaking wonderful. Love it. Absolutely love it. Anyhow, gosh, that looks so good. What I need to do is I need to text Mark, find out what the deal is with the composite video. There's got to be another missing part that connects the SCART to composite video. So the audio would be working, but definitely not the video. So the RGB might work. Oh, do I have a way to test that? Believe it or not, I don't have an RGB SCART cable because I always take them and I cut the connector off. And that's why I have these extra SCART connectors, because I cut these off and I just install a DE9 so I can plug them into the back of the monitor or any 1084. And unfortunately, that means I just don't have any to test with. I have no reason to believe the RGB through it wouldn't work, but because the composite's not working, we would not have sync. So it definitely needs to be fixed. What's going on right now where the composite doesn't work. Otherwise, there's just no way that it can actually work. Okay, I went ahead and I installed the mods. I'll zoom in a little bit. There are 2 on here, but this one is not actually required. This was there because I ripped a bunch of the traces. This was from before, and this is a ground plane, and I just wanted to make sure that the ground is definitely connected. I'm assuming it was connected because the monitor is working perfectly. Anyhow, the SCART composite video input is this pin, and I'm covering the trace a little bit, but the trace goes this way and it goes all the way up here, and it makes its way right to where this red jumper link is installed. And this side of the jumper link is actually connected to the yellow composite video input jack on the monitor. And this one is installed on Mark's monitor. It's on the other side. I just didn't feel like getting the jumper link on the other side. There's a bunch of wires and stuff in the way. So I just put it on the back side. His has that, mine doesn't. So now that connects the composite video on the SCART adapter here to this jack right there. So you wouldn't want to plug two different devices in simultaneously because that jumper link just connects those together. But we can test that this is all working by going inside the yellow composite jack here, and we have continuity mode, and I go to the same here. If I can get the contact, there we go. We have full continuity. And that's because it goes from there to right there. And that is the composite video jack. As for the audio, one of them goes to there. Where does the other one go? To there. So those are two resistors. It brings them up to this area over here somewhere. It combines these together. It does it through these resistors, so it's not just shorting these two. And that's because this has mono sound. The stereo one will have a different arrangement. In fact, the PCB is a little bit different looking at Mark's monitor versus this one. Anyhow, this should fix the composite video on the SCART adapter, and theoretically, from an RGB perspective, this probably would have worked anyways, and that's because the composite pin, which is also the sync pin, besides going up to this jumper link, also made its way to one of these jumper links and over to the two RGB inputs. And that would be for a sync input when the monitor is in RGB mode with the button on the front. I could have tested that by pushing the button and we would have had sync. We should have. Did I test that and it didn't work? I don't remember now. We're gonna have to test that. Okay, so let's turn this thing on. Hopefully no smoke comes out. Seems fine. I'm gonna push the button to switch to composite video and we'll turn on the PlayStation. I have it plugged into the SCART input. There we go. Looks terrible, but that's because it's composite video. But it is connected to the SCART jack and it works. So if we push this and we turn up the brightness, are we getting sync? Oh yeah, we are. And I know this because even though we're in RGB mode, the picture's not rolling on the camera. If I turn off the PlayStation, now it's rolling because we don't have sync anymore. Push that and it gets sync. So that means that that SCART video input is definitely connected to the sync input. Turn the brightness back down, push that, and the composite video works. The audio should work. I'll be able to test that once we get the back cover back on. And the blanking should work, which is the overlay stuff to switch between RGB and composite on the fly. Super cool. I'm really glad to have a monitor that has a functional SCART jack. Let me get the back lid on so we can test out the audio. Okay, case is all back together. I have it hooked up through composite video with the audio right and left hooked up to the SCART adapter. Let's turn on the PlayStation. Not getting anything. Oh, because the SCART adapter is not connected to the back. Let's try that again. Turn off the PlayStation. Okay, now it's connected properly. Let's turn it on. Yeah, we got a little flash from the video signal. Okay, there doesn't appear to be any audio. Well, that's annoying. Huh. Okay. Oh boy. Oh boy. Oh boy. Oh boy. The SCART connector is very flimsy. Gotta say, this adapter here does not work very well. I don't know if it's the plug that I installed or what, but when I push this on, it just doesn't stay on very well. I'm just gonna try to hook up the audio directly to the monitor. Okay, there's composite video. So obviously we have working sound, but it didn't work through this. I mean, I had all those resistors and jumper links installed, just like it was on Mark's monitor. Okay, well, there's another side effect of the whole SCART thing. Theoretically, if I plug the composite video, which is the sync signal as well, into the SCART adapter, and then I use this contraption and plug the RGB into the DIN, I think we should get a working picture. Okay, so for right now, the SCART is not connected. It's just the 3 RGB lines. And yet it's completely has no sync whatsoever. And I just plugged the SCART adapter in with the composite video, and there we go, perfect sync. And that's really working because the sync pins that are on the DIN jacks is the same thing now. As far as I'm aware, it's the same thing as the composite video input on the SCART jack. So I can push this, and now we're looking at composite video, and now we're looking at RGB. Okay, I don't know what my camera's doing. Sorry about the focus hunting there, that was weird. So the other weird thing is I don't even need to plug in the SCART adapter. I could just plug this cable directly into the video jack. So I mean the yellow jack, and there it is. It's in the yellow jack on the back of the monitor. And just like before with this, I could switch between composite and RGB, and it totally works. So there we go. And that's just because the yellow jack on the SCART input is connected directly to the same as the RCA jack on the back of the monitor. That was that jumper link that I just installed. Was there just a little bit of sync loss? No, maybe not. Yes, there is. There's a little bit of loss of sync. Interesting. Okay, I just plugged it directly into the little adapter on the back of the DIN jack instead of into the composite video jack, or the same thing on SCART. It was losing sync a little bit. There's obviously a slight difference between the sync input on SCART and the one on the DIN jack. But the funny thing about that is if we were using an RGB SCART cable for the PlayStation, I think we would have those slight sync issues as well that we were getting with this, theoretically at least. And it is interesting because looking at RGB now, and if I push the composite video switch, notice there's no video anymore. So it's almost like the sync can come in through the composite video, or it can come in directly on the DIN jacks. And right now it's coming in on the DIN jack, and you can see it's working. But let's move the video cable back to the yellow jack, back to the yellow AV jack. There it is. And that's what, now I can switch between composite video. Oh yeah, there's a loss of sync happening. You saw it like rolled there? Huh. Well, now it looks fine. Now it looks totally fine. Nope, we're getting little issues there. Okay, well, this mod, while it made my PlayStation work, it's, well, plugged into the RGB DIN jack. I don't know if the SCART's gonna be fully working because this is problematic. Okay, yep, and it's happening here. See how it's like jittery a little bit? Let me move it back to the other contraption. So it's going into the DIN jack directly now. And now, yeah, perfect. Rock solid. Is it? Yeah, perfect, rock solid. No issues. All right, well, I'm gonna have to talk to Mark about this. I don't really know what the solution is for this problem. We either missed something on the schematic or something. I'm gonna have to ask him to do a little bit of testing. Okay, a bunch of time has passed, and this project, which was supposed to be something that was easy, actually turned into pretty in-depth, but I think it's a good thing because I think what we've come up with, and by we, I mean myself and Mark at the Retro Channel, I think we've come up with the ultimate SCART mod for the Commodore 1084, these Philips boxy ones. So, what's changed since you last saw this monitor? Well, I've undone pretty much the original sync mod that I did, the one that was on this paper, has a bunch of handwritten notes on it. I've gone ahead and I've removed the components, and I put this monitor back to stock, the way it was originally. Not totally the way it was, because there's still a SCART jack on here, but I've taken off that sync mod. So the TTL and analog DIN inputs, they work exactly like they did before, which means the PlayStation, if I plugged it into those, we would get the garbled screen, exactly like I had at the beginning of this video. What Mark and I have come up with is basically, as I said, the quintessential SCART mod for these monitors. And there's a reason why I undid all the mods on here, and that's because we could never get it working quite right. Those sync issues we had with the PlayStation when they're hooked up to the DIN input, I was having them on this monitor, and Mark was having it all the way in Australia on his modified monitor because we were modifying the monitors in the same way. It seems that original sync mod mostly works, but not completely. So we figured out a better way to get the PlayStation hooked up to this monitor that doesn't involve using the DIN jacks. Well, doesn't entirely involve using the DIN jacks. Now, what we have here on this paper is lengthy instructions on how to apply the SCART mod to your monitor. And essentially what we're doing is we're adding some resistors that are going to be taking care of the sound on the SCART connector and bringing that to the correct sound circuitry. We're adding, or you have to check for the existence of several jumper links. Sometimes they're there, sometimes they're not. There were some on my monitor that Mark didn't have, and vice versa. So there are 4 jumper links that you have to add. You also have to remove a jumper link, and it's this one I have my pinky on, and you have to replace that with a diode. And it says here, replace with a 1N4148 diode, band facing the front of the monitor being this way. And then what happens is the instructions diverge because we found that the stereo monitors have some differences to the PCB versus the monaural monitor or the normal 1084 without the S. And that's what I have here. So there are instructions 5, 6, 7, 8, and 9 for this monitor. And basically it's like install the SCART connector, install a jumper link between 9206, which actually is this red wire, which I already talked about before. If you have a jumper link 9289, it was there on my monitor. I had to remove that. I forgot exactly where that was. Oh, it was right there, 9289. I can see the holes where I've removed it. You have to install a 22K resistor at R303 and install 2 5K6 resistors, or 3 of them in these positions. And that is all for handling the sound. It's bringing the sound, or it's combining the right and left audio, and then it's bringing that over to the RCA jack. So it's basically hooking this up to the audio circuitry. And what's nice is it does properly combine the right and left audio, and it does it in a nicer way than simply joining those connectors together. It actually uses a bunch of resistors and voltage divider and stuff like that, so it won't overload the input circuitry on the monitor. And then this part here for the stereo monitor, I don't have a stereo monitor that I've done this mod to, so Mark has gone ahead and written this stuff up, and there's some other stuff you have to do. Install the SCART connector, move some wires around, add some jumper links, I don't know, that kind of stuff. Now, what this has the effect of doing is giving you a SCART connector, which is installed on the board there, and it works fully. If you plug a SCART cable in that just uses, say, composite video and right and left audio, that works. You get composite video and the audio all normally. If it has RGB, and the device that's connected to the connector is actually putting some voltage on the fast blanking pin, that's pin 16, then it will switch over to RGB. And that all happens while you have the monitor on the front switch set to composite. So that fast blanking input on the SCART will switch over to RGB even with the front set to composite. That is how SCART devices work. And this monitor with the mods outlined here works compliantly as a SCART monitor should work. Obviously, the big difference is this is an NTSC monitor, cannot decode PAL color composite video. So if you hook up a composite video source to this, like a VCR, it'll be black and white. But on the PAL versions of this monitor, that will work properly. This is fully compatible. Luckily, RGB over SCART works. PAL NTSC doesn't matter. The monitor can handle 50 Hertz, no problem. And that all works perfectly. So, but this is where we come up with the PlayStation problem. I undid the whole sync mod, so putting the composite video, which is this cable, into the DIN jack doesn't work anymore. So if I plug these RGB cables in right now, you just get a completely lost sync image. What I went ahead and did, and it's on the instructions here, is I added a section down here to turn the VCR switch into fast blanking. And what the VCR switch is, you may have noticed on these 1084s, there's a switch right here. It's labeled SK5 on the PCB, but on the back of the case it's labeled VCR. I don't think anyone ever understood what that switch did. I looked up what that switch did by looking at how the circuit works, and what this does is it changes the sync mode of the chip that's handling the sync decoding on the monitor. Apparently there's something for PAL region specifically called freewheel sync, which helps you decode the sync off of a over-the-air broadcast in certain conditions, and it has something to do with PAL, and I don't think it really affects NTSC people. So no one ever knew what this switch did, because if you push it, nothing changes. Even when you hook a VCR up to the monitor, it always looks fine, and you push this button and nothing changes at all. Apparently, after talking to some folks in PAL regions, VCRs, when you have a chip that's designed for decoding PAL over-the-air broadcasts, a PAL VCR can end up with like kind of top of the image, it's all torn, like the lines are all over to the side. It kind of looks messed up, and it's supposedly pushing that button in will fix that problem. I've never seen anything like that before in all my years using VCRs here in North America. Even in the early 80s, those very old VCRs, I never saw any problems with like the top of the image kind of folding over, and I saw some screenshots of what it looks like, and yeah, it's very obvious and bad, like the whole, you know, 1/8 top of the screen is kind of bent over to one side. Anyways, apparently that's what that switch does. Who knows? The chip that it goes into, the data sheet for it is old. It's from like the early 80s, and it really doesn't say anything besides it disables something and it's good for VCRs. So what I decided to do with the mod here is wire this up so when you push this in like that, is it forces the IC that switches between composite and RGB to just switch to RGB. It's the same thing as sending some voltage into the pin 16 on the SCART pin. And that's what a SCART cable that's made for like a game console will do. Is it sends voltage into that pin 16 that switches it to RGB. So the RGB that is on the SCART connector, which is wired up in parallel with the DIN connectors. These are the DIN connectors. So the analog DIN and the SCART connector, those inputs are just parallel to each other. When pin 16 gets voltage, it will enable the decoding of the RGB from either of these connectors, even when the monitor is set for composite video on the front switch. That's by design. And then what happens is all the sync processing is coming from the pin 20, which is the composite video input pin on the SCART connector. Well, this jumper link I installed at the top connects the AV yellow jack, which is composite video, to pin 20. So those are the same on the monitor. And what that means for me, when I'm trying to use this abomination here for the PlayStation, is I can plug this DIN connector into the DIN jack for the RGB with no sync. And then I can take this composite video wire, which isn't really long enough. Oh, there we go. And all I need to do is plug it into the composite video DIN jack there, which is really the same thing as pin 20 there, and push this button. And that basically will make it work because it's taking the composite video and using that sync information, and then it's switching to RGB. And pressing this button when I have this hooked up with that in the yellow jack and this in the DIN jack has the effect of switching between RGB and composite video. It's just doing it in a way that the fast blanking signal normally does, which is different than the way the button on the front of the monitor does. When you push the button on the front of the monitor, not only does it switch to RGB full time, but it starts ignoring the sync input on pin 20 here, which is also the composite video jack, and it starts looking at the sync signals from the DINs. But we know that the processing in the monitor for the DINs isn't compatible with taking regular composite video, which is what the PlayStation has, and it should work with like Amigas, Atari STs, IBM PCs, like everything else that you would plug into these jacks as before. That all works. But for things like game consoles that only output a composite video via like a SCART type cable, well, you can either just plug that cable directly into here if you have it, and it should just work. But if you don't, like me, and you've kind of made something like this, then this button, now that it's wired up a specific way, will allow you to get working RGB through this mess. So if you look closely at the switch, the way this works is the middle set of pins are either switched between ground and 12 volts. When it's out, it's grounded. When it's in, it's 12 volts being sent to the middle pins. Well, that goes off somewhere else on the monitor and changes the sync behavior, whatever. I didn't touch that. I just left that alone. But what I did do is I hooked up a 10K resistor. It's inside this heat shrink. And then a diode, a 1N4148. And the band is facing the front of the monitor again, just like the jumper link that was over here. And I'm running that with a bodge wire to the jumper link on the side closest to the monitor, because that pin on that jumper link just goes straight to the IC, which is under this part of the plastic right here, and that does the switching between RGB and composite. So yeah, like I said, what this has the effect of doing is when you push it in, it does that switching, that fast blanking switching it's called, which essentially enables RGB while the sync information is coming from the composite video jack or from the SCART or composite video on the SCART jack. It's just a way of overriding that fast blanking signal, because you might have a device that also doesn't output a voltage to that signal, and it's relying on a monitor to have an RGB mode. Well, this has the same effect. It will force that mode on all the time, anytime the front of the monitor, that switch on the front is set to composite. I know what I've just described is a little bit complicated, so I think the best thing for me to do is set the monitor back onto its bottom here, plug it all in, get the game console hooked up, and I'll demonstrate this working. All right, the monitor's on. You can see by the rolling image, we have no sync, and that's of course understandable. PlayStation is off. Turn on the PlayStation. Now, what we're gonna be seeing now is the RGB, which is gonna look like a mess. There's no sync information. If I push this button, we're now looking at composite video. I gotta push the Luma Chroma button on the back. There we go. Okay, so we have color composite video. Looks as bad as normal color composite video does. Now, let's see, I've been having an issue. I think the optical drive on my PlayStation actually died because it has been acting up. Oh no, Mega Man's working. Okay, cool. So normally this intro right there gets all screwy with the RGB, but it obviously was fine there because we're looking at composite and composite always worked. I purposely have the image shrunk so we can kind of see any distortion that might happen. Okay, there's the title screen. Push the button here, no sync because this is RGB through the DIN jack because I've only hooked up RGB, there's no sync there. There's composite, it all looks good. Now, if I reach behind the monitor and I push that VCR button, like that, now we are looking at pixel perfect, well, you know, CRT perfect RGB video. And yeah, it works. Obviously, if I push the RGB button, so we're in RGB mode, we have no sync again because it's looking for sync on those pins on the DINs, which we don't have. But when that's pushed into composite, but the VCR button is pushed, now we have absolutely freaking perfect. Oh, sorry, I thought I had the shutter speed locked, but I didn't. It was in the wrong mode. So if there's any bars that you saw during that demo, that was what was happening. Okay, so back to what I was saying. Right now, the front switch is set to composite, but the back switch is pushed in, and that means we're looking at perfect RGB video. And if I push the back switch out, now we're looking at a very soft and fuzzy composite video, and it's amazing how soft it looks. There is a sharpness control on this monitor, and well, it pretty much does nothing good. But if I reach back and I push the VCR button, I don't know if that comes across in the camera, but the difference is shocking. Like incredibly sharp, looks like an arcade machine, fuzzy and just pretty terrible. Amazing, looks like an arcade, looks like garbage. Anyhow, what I'm demonstrating here is that the SCART inputs, which we're not reusing because we're sort of bypassing it, but you have to remember the RGB pins I am connected to are in parallel with the SCART jack, and the composite video jack I have it plugged into, it's also in parallel with the SCART jack, is working perfectly. And that means if we plug something in with a SCART cable, it's gonna work. So let's do that. I found something in the house where I have the proper SCART cable for it. Okay, would you believe that it's the Apple II GS that I have where I have an actual proper SCART cable for it. And this has 12 volts from the II GS routed to pin 16, which is the fast blanking input on the monitor. Okay, so the cable's plugged in. The way it's configured is the front switch is set in for composite video and the rear VCR switch is out. So that's disabling the fast blanking. And if I turn on the computer, there it is. Perfect Apple II GS RGB. And the fast blanking automatically enables the RGB input. That's that 12 volt signal that the II GS is sending to the monitor. And of course, since the RGB is going into the SCART jack, if I push the front button, it's going to lose sync entirely, and that's because there's no sync going into the DIN connector, and that's what this switch is looking for when it's out. But when it's in, it's going to be using the composite video for sync, and then the fast blanking just switches over to RGB, which is exactly what we have here. It looks freaking perfect, and it totally works. This pretty much confirms that any SCART device, whatever it be, game console or whatever, as long as it's got a SCART cable that's wired up correctly, is going to work with this monitor now. Isn't that awesome? How about we test some CGA? So I have a Pentium motherboard with a CGA card, and I'm going to be using a DE9 to DE9 straight through, and I have an adapter that goes from DE9 just to the TTL input on the back of the monitor. Oh, and you know what? While we're at it, I'm going to plug the composite video from this card into the monitor as well, and we'll be able to compare composite CGA from the TTL CGA. Okay, if I turn this on, What we're looking at there, oh, you probably can't see because it's too far away. Very fuzzy composite video. Very, very fuzzy. But if I push the switch, now we're looking at razor sharp TTL RGB. That's through CGA, the TTL input, and that looks awesome. Let's plug a keyboard in. All right, there it is. There's CGA looking absolutely perfect. Just the BIOS screen, of course. I don't have a hard drive plugged into this. Now when I push this button, now we're looking at very hard to read composite video. All right, for the final test, I got the Amiga 600 hooked up through analog RGB through the DIN connector. That's the analog DIN connector. Let's see if this thing works. If it doesn't, I will scream because I've been working on this so long. Oh, I gotta put the button on the out position. Theoretically, I guess I could hook the composite video output of this Amiga to the composite video jack, and then I could use it in the CVBS position with the button on the back pushed. The Amiga takes a while to boot. That's why we're not seeing anything. And the kickstart in here, there it is. It freaking works. And it looks perfect. Absolutely freaking perfect. That is a success, I gotta say. A real, honest to God success. So with that, this video I'm gonna say is a success. It didn't go where I thought it was gonna go. I thought it'd be an easy video for the second channel to do a mod on this monitor and it would all be easy. Little did I know that this would turn into multiple iterations and a bunch of different modding and unmodding. But in the end, this monitor is working exactly how I want it to work. I wanted to be able to use my PlayStation 1 and the PS2 with this monitor directly and have full RGB on it, and I can do that now. And as a bonus, I can now use any SCART device, whether it's composite or RGB, and that will just work as well, which is super exciting because I'm pretty sure I have a couple other SCART cables now that I think about it floating around. I just never thought about using them because there was really no easy way to do it. So I think if you have one of these monitors, it's definitely worth trying to do this mod. It's really relatively easy. I know there's a lot of backwards and forwards in this video, but the reality is all you have to do is follow these instructions. Pick yourself up a SCART connector from AliExpress or eBay or wherever cheap. You're just gonna need a few resistors, a couple diodes, a few little lengths of jumper links, and then you should be able to convert your 1084, whether it's stereo version or the mono version, to have a SCART jack and be able to work with even more devices than this monitor already can work with. It's such a great monitor, but adding SCART to this monitor is basically like, chef's kiss. It just makes it that much better. This boxy monitor with the good flyback is just such an awesome monitor. I just need to print myself a better front door than this floppy one because I have another one upstairs that I printed a better quality door on and it stays closed all the way and it doesn't look like it has a loose tooth. But anyways, there we go. Thank you, Mark, for all the help you've given me. A huge, huge thanks to Mark at the Retro channel. Definitely check out his channel if you haven't already. He'll probably make another video about this, a better one than me, about adding the SCART jack to this monitor. And it will be based on these instructions here. And also they may change between, oh, look at that. The static holds it up. They may change between now and when he makes a video, but I will link to these instructions in the description below. I'm not sure where they're gonna be, maybe Mark's webpage, maybe my GitHub, wherever, but they'll be there for anyone who wants to do this mod. I highly recommend it. Obviously it works for North American monitors, obviously works for the PAL region monitors. I think we've covered all the bases. If not, definitely let us know if there's any issues. Let Mark know, he's the expert at this stuff. And yeah, that's it. So thanks to my supporters, names are up the side of the screen. You can become a supporter and help me make this my full-time job, which is what it is, but it will really make it that much easier for me. And subscribe if you haven't already done that. And I think that's gonna be that. So stay healthy, stay safe. I'll see you next time. Bye.